Hi there, this is Azul Maksud. Today I am with real-time cost savings project with kOps. This is cost saving project with Kubernetes because when you are using the EKS, that means for AWS, or AKS for Azure, you have to pay extra for the Kubernetes management. I'm saying for AWS, you have to pay extra money for every cluster in the EKS. But some companies, they don't like to spend that kind of money. So cost saving only not the resources, others EC2, RDS, VPC, or either way. Also for Kubernetes, how to manage. If you guys are managing Kubernetes yourself by using the kOps, Kubernetes operations, it's called Kubernetes operations. So this is vastly used in the applications which applications ownership is with you or with us. That kinds of applications are actually used vastly because to save the money. But problem is that you have to do the patch management. You have to do upgradation sometimes. You have to keep an eye always to see if my kOps is working or not. So yes, I'm really happy today to bring up this kind of cost saving project, and you can add this one in your resume also. You can explain this one in your interview also. This is for Kubernetes powered scalable application deployment with auto scaling and kOps. So this is really interesting, and I will suggest to see, not only to see, I will suggest to do the hands-on, some sort of extensive hands-on. Please do. Also, I am sharing these guys with my DevOps 0 to Hero here inside the Kubernetes part. Where the Kubernetes here, you can go there, then you can take this one there. And this is my YouTube channel, and if you go to the playlist, if you follow my playlist here, I think you can get lots of things, especially for the freshers. And my videos focusing basically for the freshers. Also the experienced guys can brush up your experience there, because DevOps is not that okay, I just learned, no need to be rethink. When I was making this video, then also I found that, oh my goodness, this command I forgot. So please, for the experienced guys, also do the hands-on. And I will suggest this one especially because when you are using the bare metal with Kubernetes, that means kOps, this kind of project paying high. Okay, this is tricky something I am saying. I think you will like it. Okay. So first of all, see kOps versus EKS. I am the AWS guy, so I'm taking the EKS. Which one to choose? Feature, kOps, Kubernetes operations, EKS, Elastic Kubernetes Service for AWS. Managed service. In the question of managed service, no, kOps is not managed. kOps not managed. User manages the control plane and worker nodes. So here I will show you how to create the control plane, that means master node and worker node, both. So lots of layers, my goodness, lots of networking inside there. Then EKS, yes, AWS manages the control plane. So in the EKS, AWS manages the control plane, not the worker node. Actually, they are managing also worker node from the back side, but you have to create the worker node. Okay, so basically they are providing the control plane. So also the updating that one. Ease of setup. This is complex, too much complex. My goodness, you will see in the hands-on. It requires manual setup and configurations. Everything manual. The question may become like this way: have you ever deployed Kubernetes manually? Manual setup. The other way, the question is coming, poking the kOps, not saying kOps. Of course, if you say yes, I did a EKS, no man, this is not EKS, manually. EKS simplified and managed by AWS. Then infrastructure requires EC2 instances for control and worker nodes. Then AWS handles control plane, user manages workers. It looks that user manages workers, but created actually by AWS. Okay. So here is the cost lower for large clusters. No control plane charges. That is the main thing. Okay, please memorize this one for your interview. How have you saved money using kOps? Why? How? Because no control plane charges, man. And here you see higher due to control plane charges in the EKS. Just remember or memorize this one. No control plane charges in the kOps, because control plane is you or I, we the people, the controller. Then flexibility, highly customizable, full control over Kubernetes, limited customization. Upgrade, manual, this is the problem, manual rolling upgrades for Kubernetes versions. This is the problems. Always think the pros and cons, both, not only pros, also cons, conditions also you have to see. Okay, so every good things has the bad things also. So upgrade you have to do manually. Keep in mind, I am giving the red color. But managed by AWS with minimal downtime. But the good thing is you are paying money, everything doing AWS. Then security. User handles cluster security setup. AWS integrates IAM, VPC, security best practices. So kOps, you have to handle security. So this is you have to do yourself, but AWS giving identity access management, VPC, and other things. Then networking, customizable, supports Calico Flannel. So Calico Flannel you have to do inside where network, also lots of networking. I'll show you. Then integrated with AWS networking VPC. So networking VPC automatically it is integrated there. Then scaling, user defined with auto scaling options, managed via EKS, managed node groups. Multi-cloud supported, AWS, GCP, on-prem. So especially for kOps, you have to think that this is for on-prem. Okay. Yeah, the question may be coming. Have you deployed Kubernetes, the bare metal or on-prem? Yes, I did. How? kOps. Okay. Then here is multi-cloud, only AWS is normal. Community support, strong open source community, backed by AWS. Compliance, user responsible for compliance. AWS provides compliance certifications. So when to use kOps? You want full control. Okay. Also another question is like that. Your client wants the full control or fine-grained control. Two kind of words. One is full control, another one is in the industry fine-grained control. That means the fine-grained means all the grain in your hand. Okay, so you have all the control in your fingers. So that is fine-grained control over the Kubernetes cluster configuration. How do you deploy them? Which one you will use? EKS? You are the AWS guy. Which one? EKS, right? Don't be fool, okay? Please. When a full control, fine-grained control, think about only kOps. Because EKS, AKS, GKE, the other one is not for the full grain. The one for the cloud managed, cloud controlled. Then prefer cost efficiency. When cost is coming, then also is coming the kOps. For large scale cluster without AWS, EKS, control plane fees. Man, saving money too much. Then need a multi-cloud or hybrid deployment. Yes, that is another kind of question. That kind of question is coming for the senior level. It's coming like you need the multi-cloud cloud actually. uh, so which one you have to use EKS? No man, kOps. Hybrid deployment EKS? No, kOps. When to choose EKS? Managed service. I'm not going like that. So set up without complex manual Titan integration, Okay, so compliance. Okay, so now the hands-on. Let's go to the hands-on. First of all, we have to create the VPC. So let's create one VPC. That means for any microservices or any kinds of isolation, we need extra VPC. So VPC and more. We are going here. We are taking the name like which one? kOps VPC. Taking like this way. And CIDR, this is good. But number of SE to SE is okay. And to public subnet and private subnet and NAT gateway in one. Okay, S3 gateway you can take, but no need also here. It's creating. It will take times for NAT gateway to activate. Yeah, always it takes times. We're coming back. Yes, it looks done. Let's see here. Always please recheck the VPC, especially the resource map. Let's recheck this one. Start to come here. IGW is connected with public. See the left side. So public route table, public subnet. This guys, public subnet. Then kOps, VPC S3. This is also in the private, but I need the NAT public subnet, public 1, US East 1A. NAT is connected with private. See here, private. Two route tables for two subnets. NAT very much secured. Route table also separate. Okay guys, so now we have to go to EC2. We have to create master and worker two EC2s. Launch EC2. Then without giving the name, I'm just creating first Ubuntu. Okay, the number is 2 I'm giving. Okay, so T2 micro is not enough, so I need that T2 medium, this one. Instance type actually TPR, I'm using my default one. If you don't have, just get from here. The network, I have to edit this one because I have created kOps VPC. Now I'm entering into the kOps VPC. I need to have the public IP. That means it should be enabled. Okay. Then security group. Okay, create security group. All traffic. I'm just adding all traffic. Easy. TCP, all traffic, custom, anywhere. Okay, it looks good. Okay, now just create. It's launching the instances. Come here, it should be 2, right? First one making worker node. Oh no, master is fast, man. Master. Why not changed? Master. Second one is worker. You can give the name node like this way. That's good. It's also node. So let's copy the master public IP. Then let's go to the mobile extern session SSH, Control V, specify username Ubuntu, private key is okay. It's coming. First of all, sudo apt update, always do, because lots of packages are coming. I think every day new packages coming. So without update, we should not work. It's coming update. It's done. So Control L. We're changing the host name. Okay, so sudo vim. Host name is inside the etc. This is also interview question. etc host. Then I beside the local host one space. I'm giving the name like kmaster, kOps master. Okay, meaningful name. Okay, ask colon wq. So after changing, I have to do sudo hostnamectl. Host name control ctl, then set. I have to set the host name. Host name, which one I have given? kmaster, right? Kmaster. Okay, it's not enough. I have to exit. Then I have to come back with R. Just press the R. See here, name is changed. Kmaster. Now we have to install Kubernetes. So I'm sharing this docs with you guys. Already shared in the GitHub. You can see there. Okay. So lots of for curl apt transport https is coming. Okay. It's coming. We have to see the free command after swapping. This is 00 should be. It's done free. That means sudo mount. This is worked. We have to mount a mount -a, and then we have to see the free command. Then sudo modprobe overlay, sudo modprobe br and net filter. These two guys you have to do. So overlay network and net filter, br net filter. We have to install here. Then we have to add settings to sysctl. So settings is here. I'm taking all the things together for module also. Okay, lots of things I've added in my GitHub already. Enter. So when kOps, that means Kubernetes operation, we have to install everything. If it were the EKS, then no need. That one is the backside automatically managed by AWS. So we're in the root kmaster right now. Control L. I see the free -h. All I see, have to see memory and swap. How much should be? Okay, then I have to add cryo repo. Then after adding, I have to install the cryo repo. Control L. So this is the add cryo repo. This is one. It's coming. Skirt. Control L. Then I have to install cryo. So sudo apt update first, then apt install cryo run c -y, that means yes. Okay, it's installed. Now I have to update cryo cider subnet. So sudo sad stream editor. So this is the breeze and conflict. It's showing that cannot read this one. That means no problem. That we need only one. It's showing one problem. That means another one is working. Then I have to start and enable service, sudo systemctl daemon reload, then restart cryo, enable cryo, status cryo, we have C. Then at last cryo is active. That is the main thing to come to the cryo. Okay, that is the main thing. Control C. I like this. So in the master node, this is right. So in the master node, I have to initialize now control plane. So master node has a control plane. First of all, let's see ls mod grep beer net filter. This is available or not? Yes, this is available. Then I have to enable kubelet service. Okay, kubelet service is enabled. Then I have to pull container image with multiple CRI sockets. Okay, so I have to pull the container images. So sudo kubeadium config image pull CRI socket Unix. This is the location where run CRI cryo. Actually, we see the cryo socket. I have to pull. It's coming after making enabled or working the cryo, then the socket needed. Then I have to create the cluster with this cryo socket. So everything in the kmaster, that means master node. So this is the sudo systemctl -p space -p, that means port is coming. Then sudo kubeadium init, then pod network cider. So this is I have given. The next line is coming like that way in the bash \, then CRI socket, then Unix. This is the path we have given already. It's coming. Now I have to configure kubectl using commands in the output. It's good, right? See here, kubeadium join has given the token. Okay, we need this one, kubeadium join, but not now. So I have to export kubeconfig. This is the path, etc kubernetes admin.conf. So path is exported. Then kubectl cluster info. Let's see that status. I have to see. So Kubernetes control plane is running at this IP and port. Okay, so maybe we forgot the kubeadium join token, because with kubeadium token join token, kmaster is talking with the worker. We can take it from here. But right now assume we forgot. Control L. Then if this is happen like that, then kubeadium token create. We can create the token print join command. So this is created, the join token. Control C. Now let's make a file for join.txt. Okay, so nano, I like nano also. Join.txt. Right click, then Control O, enter, Control X. So we can get join.txt already inside. Same thing, right? Same thing. Always recheck, please. Okay, now kubectl cluster info. We have to see our cluster is working or not, to recheck. kubectl cluster info is running. So when kOps is used, you have to say many times cluster info, this guy, because this is managed by you, right? kOps. So this is not the EKS that Amazon managing. Now install Kubernetes in the Kubernetes worker node. So let's go to our worker node, copy the public IP. We have to have one more session, right? Control V, username Ubuntu, advanced, use private key. So first of all, let's do update and upgrade, fully upgrade this command altogether. We have to update and upgrade. Then we'll change the name also, because name should be this one, Kubernetes worker node. That means kworker. We'll give that one. Okay, it looks updated and upgraded altogether. So first of all, let's go to the sudo su root. That's good. Now vim etc hosts I insert. So I'm giving the name like Kubernetes kworker. Okay guys, ask colon wq. Now I have to change the hostname ctl, right? So no need sudo because root user. So hostname ctl, hostname control, my bad, hostname ctl, then set hostname kworker. Now exit it. Okay, exit from root. Now exit from all the server. Now R. See here, kworker has come here. Control L. Okay, now same thing at the as our master, all the commands I have to give. Okay, I've shared with you guys in the GitHub. Please follow those steps. Okay, now step 2, I am here. It will take a bit time. We are now inside the fs tab. You have to see this is the commands are here. Control WQ. Then we have to mount. It's done now. Free H. We have to see is done or not, mounted or not. Swap should be 000. That means this is mounted. Okay. Then we have to do overlay and other commands, making some quicker. I'm taking as much as possible. Okay. Yes, our cryo status is good, active and running. It's very good. Control C. Now we have to add this worker node. This is worker, right? With master. So we have already the join token, right? So come here, Control L, ls, join.txt, get join.txt, just copy from here. Okay, Control C, then right click, then we have to add CRI socket. Okay, I'm copying from my docs, so it looks like that. CRI socket, this is the location where run CRI or cryo.sock. So yes, so kubectl get nodes, we have to see this one in the control plane, run this on control plane. That means master, to see the node join or not. Let's see here. Yeah, it's joined, right? K worker, this is joined. Control plane, this is the master. Ready? Master has the control plane. K worker does not have the control plane. Okay, everything version, age. This is the minute, this is the second. Looks good. Now we have to create one more node, like this worker node. We have to create. Okay, so launch instance. We are giving like name worker2. Worker node 2 we can give like this way also. Ubuntu, then t2.medium, we have to go this one. Keep here, we have already. VPC, kOps VPC, auto assign is enabled. Then firewall, we have already firewall. Let's check this one. This one we have taken, right? We can make extra 20 storage. GP3 is coming, everything. Okay. So this is worker node 2. That means we have to change the name here. Worker node 1. This is, let's give this one. So take here from public IP. So we have to have one more session. Host, remote host. Specify your name, Ubuntu. Then private key. Already come. So Control L. Same thing we have to do with worker node. Worker node 2. First of all, let's rename the name, right? So sudo su, let's go inside vim / etc hosts I, then k worker 2 -2. Okay, wq host name ctl. Oh my goodness. Host name ctl. Okay, then exit from root, exit from server. Come back, see here worker 2, right? So now in the worker 2 we have to do same things. First of all, update and upgrade. Then I have to add Kubernetes repositories for Ubuntu. It's taking a bit time. Yes, then one more command. Okay, then another command. I've shared everything. Then install kubelet, kubedm, everything. Okay, L. Then I have to do swap. I have to see here sudo sed, then swap, then this is the location. So I have to see swap of a hyphen a to edit this one hyphen a, then I have to edit inside I have to add this guys insert just one more line. Okay, then sudo mount hyphen a, then free hyphen h. So this guy should be 000 swap. This swap I have to make sure this one. Then overlay network and BRNet filter I have to add. So overlay BRNet filter is come here. Then I have to do one more command for sudo t is done. Then systemctl should be yes. I have to add repo install package. Lots of things for the bare metal needed. AWS doing in the EKS lots of help for us. Enter. Then oh my goodness, kOps really tiring. Another command is good. Start daemon, restart. Okay, sudo hyphen I have to do. Okay, it's good. Then again systemctl I have to see everything is added or not. It's good, everything looks good. Okay, then I have to add cryo repo. It's coming. Then adding this one added. Then I have to see the status last cryo. Oh my goodness, to bring up the cryo status, lots of things we have to do. Control C, already done here. So we don't need the control plane part. Now we have to join, right? How to join? This one, kube join token. So Control C. This is our worker node 2. So it should be also one more command with cryo socket. Normally you say in the real time. Cryo socket. Okay. It's joining. Now recheck. Earlier was only one worker, right? Get nodes. See here, 2 workers. Worker 2 and worker 1. Exit R L. Now I have to install Kubernetes network plugin in the master. This is kubectl apply hyphen It calls web works network. Yes, so our here is applies done, service account, webnet created, very much important. Cluster role is here, everything is created, webnet created, that means binding, authorization, role, webnet created. 1 2 3 4 5 kinds of webnets has been created. 1 2 3 4 5 6, actually 6. This is demonstrate.app also, it's created here. So I have to do now deploy two-tier application with Kubernetes cluster. So first of all, I have to do alias. Okay, I like alias. So beam tilde slash dot bash rc. Just I insert k alias k. I have to write the alias first. Alias k equal like kubectl. Okay. Also I can give alias k get node kgn equal inside kubectl get node or nodes. Same way alias kgp equal kubectl and get pods. So pod level, node level, everything I have given here. Okay, control shift colon wq. Okay, it's done. So after doing the bash rc, I have to see the source. I have to show the source first. Source is done. Now k get node kgn, let's see working or not. Yes, kgn is working. mk get node did deb first, ls deb folder created, right? Then cd deb. We are inside deb now. So inside the deb we have to create the namespace.yaml file. So here k create ns namespace, giving the name like deb, then hyphen dry run equal client space -o, that means output should be YAML. Then greater than, that means everything from left should be, I'm giving a file name namespace dot YAML. Everything should be there, namespace dot YAML. Okay, now see inside there is namespace dot YAML file. Now we have to edit this namespace dot YAML. Then we will put something inside. Beam namespace dot YAML. See here, API version v1 kind namespace, metadata creation, timestamp null, name deb, everything is here. See, so but we don't need the spec and status part, so just make delete double d wq. Now we have to apply anything changes are created. So in the Kubernetes you have to do apply -f, which are namespace.yaml, right? Okay, it's created and applied. Then k get ns, k kubectl get namespace. So now we can see the namespace deb, this one we have created and active. So default node list public, kube system. These guys are by default created 1 2 3 4 namespaces, but we have created this one. Okay, now I have to run the two-tier application in Kubernetes cluster, so I have to create the backend.yaml. Now I'm creating backend.yaml and I'm inserting from my DevOps 0 to hero. You have to come here, Kubernetes, this backend.yaml. Just copying from here. I have added this image from my Docker Hub. This image one I have added. Okay, this image one I have added. Let's see. So kind is pod we are creating. Then metadata, namespace is dev. So label app backend, name backend. So spec containers are to go. Two-tier backend image, name backend. So API version is service. Support and service kind, both kind are needed to deploy. So name is backend service. Okay, spec like this way. Yes, everything looks good. So here is ask shift : WQ. Now we have to create frontend.yaml. Frontend.yaml. So here I have to insert here frontend.yaml from same Kubernetes inside. Just copy from here. I'm using the frontend, this one from my Docker Hub. Okay, so here kind is pod, kind is service, same thing. So in the pod spec, container image is here. This one I have taken, name frontend, and here is the name is SBC. This is frontend service. Okay, let's go to the :WQ. Now we have to restart the core DNS. So first of all, kgp kget pod, then hyphen namespace, kube system namespace we are taking. See here, core DNS is working, right? So we have to delete this core DNS. How we can do? Delete pod, then this one space, this one right click, both guys are right click, then hyphen namespace. Who is namespace we are using? Kube system. So both are deleting. After that we have to delete also webnet. These guys, how many webnets? 3, right? These 3 webnets we have to delete. Okay, so delete pod webnet, this one space hyphen n, then kube system, right? Space. So 3 guys are deleted, 3 and 2, total 5 guys deleted. Now we should run the two-tier application in the Kubernetes cluster. We have to create backend pod and service. So already we have the backend and frontend YAML file. So from frontend and backend YAML file we have to do apply. So when we are doing applying, then it's creating apply hyphen f like that. Okay, it's done. Control L, always see ls. We have backend and frontend. So first of all we have to do the backend apply, kubectl apply hyphen f, then backend.yaml. So backend pod backend created. The service name is service, backend service created. So there is the two kind, right? One is pod, another is service inside this backend.yaml. So we can see also, if you like, again to see. So the one is pod, another one is service. So here after doing apply, it's saying that pod created, service created. Pod name is backend, service name is backend service. See here this pod, right? Name is backend. Here the service, right? Name is backend service. So both guys are created. Why I am showing you guys? Because when I was new, fresher, too much problem was with this. Okay. I hope the fresher guys will be helped. If you follow my all the videos, especially the freshers, you will be get lots of things. Okay, so this is done. Now we can see the pod and service both, KGP, right? Kget pod, then hyphen n, our namespace is dev, right? So dev namespace, backend pod is running. That's good, man. I like it, man. Then KGP, kget pod, kget service, SBC. If I give, then also good, SBC. Also backend service. Service name was backend service, pod name was backend. So backend service has cluster IP, port number 5000. Normally backend is 5000. Okay, so backend is done. Same way we have to do the front end. So always I see front end is available or not. Yes, k apply hyphen f, then front end. So our front end pod and service, front end service name is SBC. So let's recheck get front end.yaml. So pod name is front end, service name is front end, SBC, right name. So yeah, and node port I have assigned 30,000 something. I have assigned here. Control L. Okay, so our front end and back end both, but let's see the KGP kget pod hyphen n dev name space. So front end and back end both are working and running. Status one by one, both are. So pod name is front end, pod name is back end, both are good. So here our another command, service. So backend service name is backend service, front end name is SBC, right? Both are now good. Showing 80, then 30,000 something for front end. Yes guys, let's see the worker node is working or not. It's good. It's good. Let's submit. Yeah, it's working. Worker node 1. Also, let's see worker node 2. So our worker node is connected with master node. 30,005, right? Worker node 2 also good. It's working, both are working. Now we have to do Control L. We have to do scale up and automate the flow of the cluster using replica set and deployments. So to do that, we have to change the namespace context first. So I'm copying the command from there. It's not, should be this one. So kubectl config set context, config set context current namespace equal dev. So context kubectl admin is going inside the admin Kubernetes modified. So context, we have set context, right? Inside the config we have inserted our dev namespace. Okay, now kgp get port. See here, when we have inserted dev inside the config, now no need to write kgp hyphen n namespace dev. No need to write. If you write, then also working. Without writing, also working. So this is also interview question. Every time you have to write hyphen n dev. So which one you can do avoid? You have to insert inside the config set context. Just set a set context. Okay, config set context. The namespace equal dev. If you write like that. Now I have to create backend deployment because we are going to replica set and deployment site. Okay, create deployment backend image hyphen image as usual to go slash 2-tier backend image, then replicas 2 namespace dev dry run equal client output YAML port 5000 backend rs.yaml should be go there. So it's created. Let's see here. So backend rs.yaml file is created, one extra, and we have to apply now. Anything is created, we have to apply k apply hyphen f file, which one backend hyphen rs, right? Replica set is created. Okay, now kgp see here, container creating backend, front end and backend both guys are running, but we given the 2 replica set, right? In the backend, one is created running, another one is creating. So replica set is 2 was. So kgp again, so both are running in the backend replica set. Okay, now we can delete our port, which on backend k delete, which on backend. So it should be port, the resource name is port, deleted. Take a bit time, it's deleted. Let's see kgp, see no more backend. Earlier was backend, here is no more backend, but the replica set 2 is working. We can see also replica k get rs replica set. So backend replica desired to, current to, ready to. So it's working good. Now I have to create front-end replica set. So first of all, backend creating, then we deleted backend, right? So same way the front-end k create deployment front-end, then image, this is my front-end image, I'm using the version 2, port 80, replicas 2 replicas should be, that means 2 more pod will come, then namespace dev dry run client output YAML, everything should be inside going there. Okay, let's see ls. So our front-end rs replica set is created. So after doing that, we have to delete first front-end. Let's apply first. Okay, apply hyphen a file, then frontend hyphen rs.yaml is created, kgp. Okay, so here is this frontend we have to delete because our frontend to replica set is working. Nice. So k delete pod frontend is deleted, kgp. See here, now without frontend and backend, only replica sets are working. Good. Now we have to expose the backend deployment first. This is the command kapps expose, that means kubectl expose deploy, then backend port 5000 namespace dev dry run client output YAML. So everything, the arrow, right arrow, that means backend hyphen deployment.yaml, it should be there. ls. So here is deployment, backend deployment.yaml has been created. One more. Now let's see get backend hyphen deployment.yaml. So here is the backend deployment.yaml has the service, right? Kind service, metadata like this way, labels, name is backend. So actually our name was backend sbc, backend hyphen service. We have to give that one here. Okay, so it should be Vim insert name backend hyphen service. Okay, wq. So we got the service here. Same way we have to create also frontend expose, k expose deploy frontend port 80 type node port namespace dev dry run client output YAML frontend hyphen deployment .yaml should be there. Control L get frontend hyphen deployment.yaml. So here kind is service. Okay, so label name should be frontend hyphen sbc. We have used that one, so we have to change the name here. Get, that means Vim insert name is here hyphen sbc. Okay, now here is the selector target port. Under the target port just adding node port. Earlier was 30,005, now giving the 30,006. Okay, so target port, then node port is here, colon wq. So I have to delete now all the services. K get sbc, two services here, right? So k delete pod, actually services sbc, this one space this one, both are deleted. So let's see the service, no service in the dev namespace. So now everything is cleaned. We have to apply our backend hyphen deployment.yaml first. Control L, always see ls. K apply hyphen f backend hyphen deployment.yaml is done. Also at the same time, quickly we can do k apply hyphen f frontend hyphen deployment.yaml. This is also done. So k get deploy So backend and frontend both deployment are working. Now let's say KGP, kget port. So backend and frontend both has 2 to 4, right? 4 ports are working. So let's delete the frontend both port. Okay, delete port the frontend space. So both are deleted. Okay, now let's see, again created, right? Earlier frontend last class 4 is 9j, see here nk 9f, that means 0 downtime. Now let's see in our real-time port, should be changed 30,006 should be now. Oh, 6 is working. Wow, good. Our port is working, man. This is called scalability. It's not working because this is 30,005, right? It's not working. If we give the 6, it should be working. It's working also. See? It's working. So let's see our master node. Copy. Worker is working, so master should be working also, right? Okay. Should be 6. Yes. Reversal summation, both are working good. Now I will install kOps, then run Kubernetes cluster with kOps. So this is the high time now to do that. So first of all, I have to change the front-end deployment. Then I will add the load balancer. Okay, beam front-end hyphen deployment. Then so instead of node port, I have to add load balancer. Type, so type is load balancer now. So service frontend, type is load balancer, WQ. So after changing, of course, I have to apply again, right? Apply hyphen F frontend hyphen frontend deployment is changed. So k get SBC service. So this is the service now, load balancer. See, it has the load balancer. That's good. Now I have to zip the dev folder into home/Ubuntu directory. Okay, let's go to cd, then pwd, the root. So tar, then czf, that means compress. This is the location home Ubuntu deployments dot tar dot gz, then the dep, the location. Let's go to the home Ubuntu ls. See here, inside the dep, everything is now deployments dot tar dot gc. So inside that dep, right? This is done like this way. Now let's go to the left side, see the name, expand Ubuntu, inside the Ubuntu deployments dot tar dot gz, this one. Okay, right click, download. Okay, right? It's downloading now. Now we are doing something magic. Come here. Now delete all the nodes. Okay, terminate all. Now coming in the action kOps. So we are making one more EC2 name kOps. Okay, see here Ubuntu just smallest T2 micro, 1 vCPU, free tier I'm using. How much easier making, man. kOps VPC Noble security group. Okay, making one more noise. Add security role. See here like HTTP custom anywhere, also HTTPS custom anywhere. Just create a launch. Okay, so this is our kOps running, taking the public IP. See, now these guys are dead, they're no more. Okay, so I'm making one more session, this one, Ubuntu, then private IP, private key actually. Feeling tired, man. Okay, looks good. Making some bigger. Control L. Sudo apt update and sudo apt upgrade -y. Yes, it's done, updated and upgraded. So let's install kubectl from this location. Install and set up kubectl on Linux. So with version for Linux 1.32, we can use this one. Okay, Control C or ARM64, that one also. Okay, I think my one should be this one. It's coming. ls, see here, kubectl. So we have to keep the execution mode, right? Sudo change chmod plus x, then kubectl ls. Now see the color is changed, that means it has the execution power or permission. So I have to move this one. Now its location should be sudo mb mob kubectl. It should be user bin. Okay, so see here, it's no more here, but should be in the user bin. Now I have to install unzip. Unzip first, then I have to install AWS CLI. Okay, so this is the command for AWS CLI. It's coming. Okay, So Control L, AWS hyphen version is good, ls. So we don't need these two guys, AWS, this folder, these two folder. We can remove rm hyphen rf AWS. Another one is AWS CLI.js. Okay, both guys are deleted. Now I have to install kOps. Okay, so kOps command actually you can get from the URL also. I'm showing the URL I'm using here. So Linux, Mac. So this is the kop command. See here it's for AMD 64. So our kubectl also was AMD 64. Very much important, these guys. Okay. See here it has kOps. So chmod plus x kOps ls, color is changed. So we have to move this one also to user local bin actually. Sudo mb kOps slash user local slash bin slash kOps. The location, kOps location is there. Ls no more here. Now I have to do AWS configure. AWS configure. I need access key ID and secret access key. For this reason I have to go to AWS Identity Access Management. Let's go here. Users. We have to create one more user. kOps user. Give the meaningful name, attach policy directly. I'm giving the administrative access. Administrator access, then just create user. So one more user, kOps user, credentials, security credentials. I need the access key, right? For CLI, right? Confirmation, create. In the real time you have to download this one in the project, but after this demo I'll just delete. So copy, I can show you guys. No worries, I'll delete. Okay, secret region name US East 1, then JSON output AWS S3 ls. So these guys are in my S3 bucket. So normally to see AWS S3 ls is connected or not. Now I have to create cluster with kOps. This is the command. So I'm changing first. The name should be the S3 bucket name. Your S3 bucket name should be changed here. I have the bucket name here. So my bucket I can use this one here. That's good. Okay. So here say kOps create cluster. Name I have given February 25. Then kOps Kubernetes .local. I've given this name. Node count 2 nodes. Then cloud AWS Jones US East 1. It has given 1B, but June I'm giving 1A. State S3 colon / my bucket name master size t2.medium, node size t2.medium. Okay, so node count is 2. So one is master, one is node the slave. Okay, it's good now. Looks. Enter. Yeah. Enabled. Enabled. Now I have to export the S3 bucket. This one I have used, right? Export it done. kOps state store. We call S3 this one. Okay, now I have to say kOps get cluster February 25 Kubernetes.local AWS US East 1A zone cluster is created. Now I have to update the cluster for it to come into the action. So kOps, then update, then cluster hyphen admin hyphen yes. Cluster name is this one, right? Okay. So guys, it's done. It should be ready in a few minutes. That means it should be ready, right? Yes, see here. How many? 1, 2, 3 control plane and 2 worker node. Okay, this for master. 2 guys. Also one load balancer is created here. And let's see the overview. Auto scaling group also created. Elastic IP already I had. Load balancer 1. Auto scaling group is 2 here. So auto scaling group for control plane and worker node. 2 auto scaling group. Desired control plane is 1, worker is 2 instances because desired capacity is like that. Okay. Now let's see the cluster info. Control L, kubectl, cluster hyphen info. So guys, kubectl cluster info. Kubernetes control plane is running at this API. February 25. This is the name. And coordinates is running at this one. Everything looks good. To further debug and diagnose cluster problem, use kubectl cluster info dump. I don't need. So kubectl get nodes. So here is 1, 2, 3 nodes are ready, and this is the control plane. This is for master node. So everything looks good. Now guys, let's go to the left panel. Yes, we should upload our the desktop. This one is the desktop. It's coming. ls, it has come back. Let's see again. We should do now unzip. Earlier was tar -czf, now xzf. Which one? Deployments.tar.gz, right? Now see, we have the deb, so we don't need this one now. rm, then deployment. This one no need. So ls, we have the deb folder. So let's go to the deb folder. cd deb ls. Our everything is there, right? Control L. So our backend.yaml, frontend rs, namespace.yaml, everything is there. Okay. Now kubectl apply -f namespace.yaml. We have to do that first. So kubectl apply -f, then namespace.yaml. Yes, dev is created. So let's see the cat namespace.yaml, inside is dev, then kubectl get ns namespace, so dev is created is here. Okay, so now I have to run backend rs, control l ls, so kubectl apply hyphen f, first of all backend hyphen rs.yaml replica set. Okay, created. Then backend deployment .yaml also created. Now kubectl get port, let's see. Get port hyphen n namespace is dev, right? Okay, our backend is working, two ports are working. Okay, now after seeing that, let's see the service. Get sbc, why like that? So backend service cluster IP also created, so everything looks good with backend. So let's go to the front end now. Control L, kubectl apply hyphen f, front end rs first. Okay, then front end deployment .yaml also done. Now let's see the ports and services again. Port, see here front end and back end both are working good. Services, so front end service here, the load balancer it has given. Oh my goodness, Ellie. Wow, good. Let's see, very good. Let's come here. Yeah, it's created. Let's see working or not. Working. Reverser summation one's working. So guys, at last this is created, man. Oh my goodness. Now kOps is pro. So the magic with front-end service, this load balancer, it has given us this one, us east 1.elb elastic load balancer amazon.com. It has given, no need our these guys anymore. So front-end sbc, that's the real thing actually. ls, let's see one more time. So cat front end deployment, see here this load balancer front end deployment we have given in the service, right? That load balancer type. So for this reason no need the port now or target port, node port, no need. It has given us this one. Okay, so this is the high availability and also the elasticity, whatever you say. So guys, this is very much important one, honestly, and it looks easy, but this is not so easy. So two-tier application deployment with kOps, that means bare metal. In the market, this is very high paid job, man. Okay, because bare metal you're saving lots of money using the kOps. If you don't use EKS, if you your company can use kOps, saving money, man. But problem is that people cannot do the manage Kubernetes in the kOps right way. Lots of CodeNS problem, weebnets problem, okay, networking problems. So please do hands-on more and more with this one. I think I have added this one in the DevOps 0 to Hero. Guys, see you again with, of course, very much important something. Take care, stay tuned. Bye.